Our problem is the density of gasoline is 730 kilograms on cubic meters at 0 degrees Celsius. Its average coefficient of volume expansion is 0.000960. And note that 1 gallon is equal to 0.00380 cubic meters.
Calculate the mass of 10 gallons of gas at 0 centigrade. If 1 meter cubic of gasoline at 0 centigrade is warmed by 20 centigrade, calculate its new volume. Using the answer to part B, calculate the density of gasoline at 20 centigrade. Calculate the mass of 10 gallons of gas at 20 centigrade. How many extra kilograms of gasoline will you get if you bought 10 gallons of gasoline at 0 centigrade rather than at 20 centigrade from a pump that is not temperature compensated?
Of 10 gallons of gasoline at 0 degrees we have to do. First we have the density of the gasoline, that is 730 kilograms over 1 cubic meter. This is equal to meters over 0.038 cubic meters. So this is equal to 27.74 kilograms.
The mass of 10 gallons of gas at 0 degrees Celsius is 27.74 kilograms.
Of cubic meters of gasoline at 0 degrees is warmed by 20 degrees. What is the new volume? So we have average temperature, it's equal to final temperature minus initial temperature, it's equal to 20 degrees minus 0 degrees is equal to 20 degrees. And we have the average velocity, it's equal to beta multiplied by average temperature minus initial velocity. And then we have the average velocity, it's equal to 0.00097 Celsius multiplied by 20 degrees multiplied by 1 cubic meter, it's equal to 0.0192. And then we have the velocity, that is equal to the average velocity plus the initial velocity, it's equal to 0.0192 plus 1 cubic meters. So this is equal to 1.0192 cubic meters.
The new volume is 1.0192 cubic meters.
To calculate the density of gasoline at 20 degrees, we need part B. We have 730 over 1.0192 cubic meters, which is the result of B. It's equal to meters over 1 cubic meter. Solving this equation, the result will be 716.248 kilograms. This is going to be the density of gasoline at 20 degrees.
The density of gasoline at 20 degrees Celsius is 716.248 kilograms over cubic meter.
The mass of 10 gallons of gasoline at 20 degrees, it will be 716.248 kilograms over 1 cubic meter. It's equal to meter over 0.038 meter cubic. So the result will be 27.2174 kilograms. This will be the mass of the 10 gallons of gasoline at 20 degrees.
The density of gasoline at 20 degrees Celsius is 716.248 kilograms over cubic meter.
What will happen if I buy 10 gallons of gasoline at 0 degrees rather than at 20 degrees from a pump that has no temperature compensed? Well, I will have some extra kilograms. How would I know how many extra kilograms I would have? Well, it will be subtracting the mass of the 10 gallons of gasoline at 0 degrees, which is 27.74 kilograms, from the mass of 10 gallons of gasoline at 20 degrees, which is 27.2174 grams. So I will have something like this. 27.74 kilograms minus 27.2174 kilograms. My result of this subtraction would be 0.5226 kilograms. These are going to be the extra kilograms I would have from buying 10 gallons at 0 degrees.
The extra kilograms of gasoline are 0.5226 kilograms.
Finally, if gasoline is involved in a temperature variation, its volume is going to change, but mass is going to stay the same. Consequently, density varies. It is clearly observed in our results, which are back myself, that when gasoline is heated, the volume expands and density decreases. So we can infer that when more is temperature, less is going to be density and vice versa.